Hey, what's up YouTube? This is Iconic, and this is my second video in simplifying organic chemistry. In the last video, we talked about all the things that are necessary from Gen Chem that you're going to need to know for organic chemistry. And now in this video, we'll actually start and get into the actual organic chemistry itself. Before we go into anything very complex, I want to show you guys how to go about looking at a molecule from an organic chemistry point of view. What I mean by that is, look, in Gen Chem, you get used to looking at molecules that are, all drawn out with all the atoms shown and all the bonds shown. But in Orgo Chem, you don't see it like that, but rather you see things in a line drawing structure. Basically, what it is you just show the carbon chain. In this molecule, let's look at it. You have 1, 2, 3, 4. 4 carbons. Right, so in organic chemistry, instead of drawing all the hydrogens and doing all that crap, instead we write it like this. That's it. Very simple. But whenever you look at it, you should know, okay, there's a carbon over here, there's a carbon over here, and there's a carbon over here. And if they don't show anything that's attached to it, then you should know, okay, there's 3, like this, 1, 2, 3. There's 3 hydrogens over here. There's 2 hydrogens connected to this, there's 2 hydrogens connected to this, and there's 3 hydrogens connected to that. I'm not going to draw in all the hydrogens, but you guys get the idea. Basically, carbon always wants to have 4 bonds, so that is why, that is why you would see the hydrogens are in the place that they are in. So get used to looking at molecules in this, in this way, because in organic chemistry, you almost never write molecules in this kind of structure. So now that you have an idea of how to go about looking at molecules, let's get this guy out the way, and let's just work with this right here. Now the next thing that I want to go into is how to go about naming this type of molecules. So whenever you have a molecule that has only single bonds, right? No double bonds, no double bonds, no triple bonds or nothing like that, but rather only single bonds, then this is a alkane, right? The title of the video, this is an alkane. And alkanes, whenever you name them, you give them some kind of first name, and then the last name will be a ane. So methane, ethane, propane, butane, and so on. So how do you go about deciding, okay, what kind of molecule is it? It's very simple. First and foremost, what you want to do is count the amount of carbons that you have, right? The longest chain of carbons that you have. In this molecule, I have 1, 2, 3, 4. 4 carbons. Do I have anything else attached to it? No, there's only hydrogen. And of course, hydrogens, you don't include those, right? So if it has 4 carbons, we give it the first name of BUT, right? BUT. And the last name, I told you, it's going to be ANE. So this is called butane. That's it. Very simple. So what do you think this is called? Let me give you another example. Pause the video and try to see if you can figure this one out on yourself. Okay, I'm assuming you guys actually did pause the video, but now I'm gonna solve this one. Well, same exact method. Count the amount of carbons that you have, right? So let's start. We have 1 carbon, 2, 3, 4, 5, 6, 7. Right? 7 carbons. The first name will be hept. And the last name, since there's only single bonds, we give it an ANE, alkane. So this, because these are all alkanes, we give it ANE ending. So this will be a heptane. And I didn't write it down, but if the molecule has 8 carbons, it'll be octane, 9 carbons, nonane, 10 carbons, decane. But basically, the ones that are really, really important that you're gonna see most of the time is 1, 2, 3, 4. The what do you call it? These ones. These are the most important ones that you're gonna see most of the time. But eventually, as you work with them, you automatically memorize it. So you don't have to sit down, math, add, prop, beat. You don't have to spend too much time memorizing it, but you'll get used to it. So now I want to just go into one more thing. Now that you can name something that has many different carbons, what if you have something attached to it? What if you have some kind of molecule attached to it? Let's just say I put I don't know, let's just take a fluorine, right? and we attached it to this carbon right here. What would you call that? Well, first and foremost, in terms of nomenclature, the first thing you do is identify your longest carbon chain. Longest carbon chain. Before you go into what's attached to it. Well, in this molecule, right off the bat, look, you have 7 carbons. So that's your longest carbon chain. And with 7 carbons, you call it a heptane. But now we also have to recognize the fact that there is a fluorine right over there. So how do we go about naming them? What you want to do is number your carbons in such a way that all the substituents, that's what it's called, all the things that are added on, all the substituents, they get the lowest numbers possible. Well, in this situation, we have a fluorine, so let's start numbering from this side. 1, 2, 3, 4, 5, 6, 7. In this way, my fluorine gets a number 2. If I were to number from this direction, right, if I put 1, 2, 3, 4, 5, 6, then fluorine would be number 6. So of course this is the better way. So this is why this one we want it to be at the second place. So how do you go about fluorine, chlorine, bromine? Instead of saying fluorine, you say 2-fluoro. 2-fluoroheptane. That is the actual name of this molecule. So if it was bromine, you say bromo. If it was iodine, you say iodo. If it was chlorine, you say chloro. Now, let's go give you a different example. Let's say I have 1, 2, 3, 4. 1, 2, 3, 4, 5. My bad. It's actually 5 carbons. And I'm going to throw a fluorine over here. And I don't know, let's just say, let's add a bromine over here. Okay, how do we go about naming this one? Well, same exact thing. First, what you want to do is identify your longest parent chain, or longest carbon chain. This one right here, you see right off the bat, there's 1 carbon, 2, 3, 4, 5. So right away you should tell yourself, okay, it's going to be called a pentane, right? Now, you want to number these carbons in such a way that the substituents get a low, overall low amount of numbers. If I start numbering it from this way, 1, 2, 3, 4, 5, right? I have a bromine that's 3, and I have a fluorine that's 4. Total is 7. Instead, if I start numbering it from the other direction, let's see what happens. I have my fluorine, this will be 1, 2, let me erase these ones actually, right? So it'll be 1, 2, 3. So instead of my fluorine will be 2, and my bromine would be 3. And we want, like I said, the rule is you want to give them the lowest combination of numbers. So that's why we're gonna number these, because this is, if we're numbering it from the left side, you will get 5. From the right side, we get 7. So we're gonna start from the left side. All right. So, oh man, I didn't mean to erase that. Okay, but the parent chain is pentane. Parent chain is pentane, and what do you call it? And the fluorine is in the second place, so we call that 2-fluoro. And the bromine is in the third place, so we call that 3-bromo. So now all of these pentane, 2-fluoro, 3-bromo, these are all, they're all parts of a whole name, and you have to put these together. Now, what's the rule in putting them together? You want to put them in alphabetical order, right? So what we call this molecule overall, you would call it 3-bromo 2. Can you guys see that? Okay, 2-fluoropentane. running out of room over here, but you guys can see that, yeah. So this molecule right here is 3-bromo-2-fluoro pentane. So now in summary, how I'm just gonna end the video right here, and in summary, whenever you have any alkanes and stuff, how you want to go about naming them, these are the rules that you wanna keep in mind. First and foremost, identify your longest carbon chain. Okay? And keep this in mind, it's always not going to be from left to right. Sometimes it's from the right. Sometimes you'll start from the left and you'll go in a different direction or whatever. Now, the second thing what you want to do is, after you identify longest carbon chain, you want to, number your carbon chain so that the substituents, right, all the things that are added to it, they get the lowest overall set of numbers. The lowest overall set of numbers. And then after that, you kind of got the idea. So you identify your longest carbon chain, methane, ethane, propane, butane, whatever. Then you give your substituents the lowest possible numbers. And then when you get all these pieces of information, you want to put them together in alphabetical order. You guys get the idea. Alright, I'm gonna end the video right here. In the next video, what I'll do instead with alkanes, I'll go into just some more complex examples. So if you guys have any questions, please leave your question in the comment section below. I'll try to make these videos much shorter if I can. Until then, I'll see you guys in the next video.